Welcome back to the Deep Dive. This is where we take on these massive, complex topics, prep guides, research, you name it, and we synthesize it all, saving you hundreds of hours of work.
And today we are tackling an absolute beast of a topic. It's really the foundation for anyone who wants to move from being a hands-on technical expert to a genuine strategic leader in security.
That's right. We're jumping straight into the deep end with CISO and Domain 3, Information Security Program Development and Management. It's so big we've had to split it.
We had to. So today, this is part A. We are focusing completely on the development part of that. This is the groundwork, the strategy, the planning. Basically, everything you have to get right before you even think about implementing controls.
And our mission here is to really pull apart the core elements you need to build a security program from scratch. We're not talking about configuring firewalls yet.
No, not at all. This is about getting that strategic alignment right, getting the formal authority you need from the top, building out your roadmap, and, securing the actual resources to make it all happen.
The source material we're using is, well, it's incredibly rigorous. So the focus has to be on that translation piece. How do you take a high-level business strategy and turn it into real, measurable controls across the entire company?
And that brings us to the single most important idea we have to get our heads around today. It's what really separates a manager from a true leader in the space.
Which is?
Security is not a cost center. It just isn't. It exists for one reason and one reason only: to support and to enable the business to achieve its mission.
Right. If people see security as a roadblock, you've already failed.
You've already failed. The whole point of all the strategic work we're about to discuss is to make sure security allows the business to do what it needs to do, but to do it securely within an acceptable level of risk. That alignment, that's everything.
Okay, let's start with that fundamental building block then. If we say governance sets the rules and strategy sets the goal, what is an information security program in practice?
Think of it as the engine. It's the execution engine for your strategy. It's the combination of your people, your processes, and all your technology, all working together to protect your information assets.
So it's where the rubber meets the road.
Exactly. It takes a high-level goal, something like, we need to reduce our risk of data loss, and turns it into actual, tangible controls that are managed, and this is the critical part, continuously adapted over time.
The analogy in the source material for this is actually perfect. It really helps to clarify these big, abstract concepts.
It does. I love this one. So if governance is setting the laws, the rules of the road, and the strategy is you planning your trip, where are you going? How are you getting there?
Are you flying? Are we driving?
Right. Then the program is the actual car making the journey. It's the execution. It's dealing with the traffic jams, the potholes, the detours. It's the living, breathing process of getting from A to B securely.
What I like about that is the continuous adaptive process part. The program can't be some static document you write once and put on a shelf.
Never. The threat landscape changes daily. Business priorities shift. The program has to be designed from the ground up to evolve. And because that's where all the money and people are, it absolutely has to deliver measurable results.
Okay, so what are those results? The source material boils it down to 6 essential outcomes that a good program has to deliver.
Yep, these are the big ones. This is what leadership is going to hold you accountable for. And number one, no surprise, is strategic alignment.
We keep coming back to this.
Because it's paramount. Your security efforts have to directly support the business objectives, they can't hinder them, and they have to operate within the risk tolerance that the board has defined. Full stop.
So if the business wants to expand into a new market, security's job is to figure out how to make that happen safely, not say it's too risky.
That is the job, exactly. Second is the core function, risk management. This is the bread and butter, identifying, assessing, and mitigating risks down to an acceptable level. It's a continuous cycle.
And third, this is where the CISM role really has to shine, is value delivery. This feels like a big one for getting budget approved.
It's everything for getting budget. You have to prove that security is cost effective and that it's an enabler. You can't just say, hey, we bought a new tool. You have to be able to say, this new tool reduced our risk in this specific area, which enabled us to launch a new service that's generating revenue. You have to connect the dots to value.
Okay, that makes sense. Number 4 is resource management.
Right. This is about efficiency, getting the most out of your people, your budget, your tech. Are you using your team effectively? Is your budget allocated to the highest risk areas? It's an optimization game.
The number 5, performance measurement.
Oh, you metrics?
The metrics. You've heard it a million times. If you can't measure it, you can't manage it. And it's a cliche for a reason. Without data, you're just guessing. And you can't justify your program to the board with a guess.
And the last one, number 6, is assurance process integration. This sounds like not working in a bubble. That's exactly it. Security can't be an island. You have to work hand in glove with internal audit, with compliance, with privacy, legal, even physical security. The goal is to give leadership one single unified picture of risk, not 5 different conflicting reports from 5 different departments.
So when we say assurance processes, what are we talking about specifically?
We're talking about all those formal activities that check if your controls are actually working. So things like your enterprise risk assessments, formal security audits, pen tests, vulnerability spanning, compliance reviews against things like PCI or GDPR, all of that.
Got it. So if that's what the program needs to do, who does it? Let's talk about the key roles, because getting the responsibilities wrong seems like a quick way to fail.
Oh, it is. And the central figure in all of this is, of course, the information security manager. That's the CISM role we're talking about. You're the one leading the development, the implementation, and the day-to-day management.
And you're the bridge between the techies and the suits, basically.
You are. You have to be. You need the technical knowledge, for sure, but you also need real business acumen. You need to understand how the business makes money, what the regulatory pressures are, and you need to be good with budgets and even better with people.
Then you've got senior leadership and the board. Their role feels pretty obvious, but what's the key function?
Their role is to grant authority. They provide the sponsorship, the resources, the budget, and the staff, and they hold the ultimate accountability. They do this formally through something called the program charter.
We'll get to that. And a key challenge with them is translation, right? You can't go to the board with a report full of CVE numbers.
Absolutely not. You have to speak their language. Risk, financial impact, strategic alignment. That's it.
And we can't forget the stakeholders. This is basically everyone else.
Pretty much all your business unit leaders, IT, HR, legal,
Mm.
you need their buy-in. If you try to force security down their throats, they will resist you at every turn. It just won't work.
Which is why things like RCA charts are so useful, to make it crystal clear who does what.
Exactly. And to manage all that collaboration, you usually have a security steering committee.
Right. This is where you bring all those different department heads together.
You do. And it serves 2 functions. 1, it keeps the security program aligned with what the business is doing. And 2, it's the forum for making tough decisions. When sales and IT disagree on a security issue, the steering committee is where you hash it out so that business leaders feel like they have a voice.
So it stops security from being seen as this autocratic department that just dictates rules from on high.
It's your best defense against that perception. It builds consensus.
Okay, so with the people and the goals defined, let's walk through the actual development lifecycle. Where does an InfoSec manager physically start on day one?
Day 1 is all about listening and learning. You have to start with foundational understanding. Before you do anything else, you have to deeply understand the business's objectives, its legal and regulatory obligations, and its overall risk environment. That means doing some high-level risk assessments to figure out what the crown jewels are.
Once you have that baseline understanding, you move to formalizing your authority. This is where that charter you mentioned comes in.
And this document is non-negotiable. The source material is emphatic about this. The charter is the formal decree from senior leadership, the CEO, the board, that officially creates the security program.
So it's your political mandate.
It is your political backbone. It defines the program's objective, its scope, what it covers. It names you as the leader, and it allocates the funding. Without a signed charter, you have no real authority. You're just making polite suggestions.
That distinction is huge. It's the difference between a mandatory program and an optional one. And alongside the charter, you're developing the roadmap.
That's right. The roadmap is your strategic plan. It's how you're going to achieve the goals in the charter over, say, the next 3 to 5 years. It's usually phased because you can't do everything at once. It connects the high-level strategy to specific, prioritized projects and milestones.
I have a question about that, though. In a world of agile and constant change, how is a 3 to 5 year roadmap not obsolete the second you print it?
That's a great question, and a very common one. The key is that the roadmap defines the destination, but the route can be flexible.
Ah.
So your roadmap might say, in 36 months, we will have a mature zero-trust architecture. That's the destination. But the specific projects you do in year 2 and 3, you'll reevaluate and reprioritize those every 6 months based on new threats, new business needs, and your performance metrics. The destination is fixed, but the journey is agile.
That makes a lot more sense. It provides a North Star without being overly rigid. So let's get into the implementation phase, turning the charter and roadmap into reality.
It's a cycle. You start by doing a very detailed current state assessment. Where are we right now? You audit everything, your controls, your processes, your staffing.
Then you define the desired target state. Where do we want to be? And the space between those two is your gap analysis.
Precisely. That gap analysis tells you exactly what's missing. From there, you create your action plan. You turn those gaps into a list of prioritized projects, each with a budget, a timeline, and a clear owner. Then you execute and monitor using your metrics to make sure you're on track.
Now, here's where it gets really practical for the tech teams. Integrating all of this into the system development lifecycle, the SDLC. We hear shift left all the time. What does that actually mean for a CISM?
Shift left just means doing security earlier in the process. And the reason it's so important is purely about cost optimization. It is orders of magnitude cheaper and less disruptive to build security into an application from the design phase than it is to try and bolt it on after it's already in production.
It's like building the fire suppression system into the walls of a new house versus trying to retrofit it later.
Perfect analogy. Let's walk through the 5 ISA phases. It starts with initiation. This is when a project gets the green light. Your job here is to define the high-level security requirements. What kind of data will the system handle? What regulations apply?
Then you move into development and acquisition, the build phase.
Yep. Here you're incorporating the actual controls. Secure coding standards for your developers, proper configuration settings for off-the-shelf software, making sure encryption is built in, not an afterthought.
Phase 3 is implementation. This is the pre-launch testing.
Right. Before it goes live, you have to validate that all those controls you designed are actually working as intended. This is where you do your vulnerability scanning, your penetration testing, your user acceptance testing for security features.
Then comes the longest phase, operations and maintenance.
By far. This is the rest of the system's life. You're monitoring it, patching it, making sure it's part of your change management process, and just generally keeping it secure as new threats emerge.
And finally, disposal.
Yeah.
Getting rid of it securely.
Securely is the key word. You have to archive or destroy the data properly and decommission the system so you don't leave orphaned servers or data sitting around creating risk.
Of course, building anything is never that smooth. Let's do a reality check. What are the common challenges and constraints that can completely derail a security program?
Number 1, with a bullet, is a lack of sustained executive support. We talked about the charter, but that support has to be ongoing. If leadership isn't visibly backing the program, you won't get the budget you need, you won't be able to hire the right people, and other departments will just ignore you. It's fatal.
Then there's the human element. Change management. People hate change.
They really do. And a security program is all about changing how people work. New passwords, new processes, more monitoring. You have to plan for that resistance. That means communication, training, and building it into your project timeline and budget.
There's also the danger of misalignment, where security gets that reputation as the Department of No.
A huge danger. If the business sees you as a blocker, they will find ways to work around you, which creates shadow IT and massive risk. You have to build consensus, use that steering committee, and frame everything in terms of business risk, not technical mandates.
And my personal favorite headache on any big project, scope creep.
Ah, yes, the silent killer. It happens when you don't have a clearly defined target state and powerful stakeholders just keep adding their wants to the project. Before you know it, your budget is blown, your timeline is shot, and you haven't even delivered the core security requirements you started with.
You have to be ruthless about protecting the scope.
You do, and you have to anticipate complexity. Integrating security into dozens of different systems, some of which might be decades old, is not easy. You have to plan for that. Trying to do a big bang global rollout of a new system is almost always a mistake. Phase it, pilot it, plan for the integration nightmare.
Okay, that makes sense. This leads us right into the next section, which is the absolute prerequisite for all of this. You can't protect your crown jewels if you don't know what they are, where they are, or what they're worth.
Exactly. This is step 1 of any real risk management process. Information asset identification and classification. You need a complete inventory.
Right. And an asset is anything of value, data, systems, people, even reputation. But let's get to the hard part. How do you assign value to these things? The source material says it's a function of 2 things.
That's right. An asset's value is based on its criticality and its sensitivity.
Break those down.
Criticality is all about availability. How essential is this system to our operations? What's the financial impact per hour if it goes down? Sensitivity is about confidentiality and integrity. What's the damage if the data on the system is stolen or altered?
The really tricky part here seems to be valuing the intangibles. Valuing a server is easy. It's the replacement cost. But how do you put a number on brand reputation or customer trust?
This is where a lot of risk assessments fall flat, and it's a critical skill for CSMM. You have to quantify the potential consequences. So for reputation, you can model the potential stock price drop based on historical breaches at other companies. For customer trust, you can calculate the lifetime value of a customer and multiply it by the expected number of customers you'd lose.
So you're not pulling a number out of thin air. You're building a defensible financial model based on potential impact.
You have to. Because if you ignore the value of these intangibles, you will always underestimate the risk, and you will always underinvest in the controls needed to protect them. It's that simple.
Okay, so once everything has a value, the next step is to classify it. What's the point of this?
The point is consistency and cost efficiency. You assign a formal label to the data like public, internal, confidential, restricted based on its value. That label then dictates the minimum required security controls that must be applied to that data, no matter where it is or who is using it.
So you don't waste money putting top secret level encryption on the public marketing brochure.
Exactly. You apply the appropriate level of protection, which saves money and effort, and you want to keep the classification scheme simple. Most companies use 3 to 6 levels. Any more than that, and it becomes too complicated for employees to use correctly.
This all has to apply across the entire secure data lifecycle, right? From cradle to grave.
Every step. The first step is create classify. As soon as data is created, it needs a classification label. This can be done manually by the user or automatically by a tool.
Then you have to store it, or data at rest.
Right. When it's sitting in a database or on a server, it needs to be protected based on its classification. For anything sensitive, that almost always means strong encryption and strict access controls.
Next is use, so data in transit or in process.
When it's moving across the network, you're using things like TLS or a VPN. When it's being used in an application, you're using access control lists and maybe data loss prevention or DLP policies to control what can be done with it.
And the final, often forgotten steps, archive and strikeout.
So important. You archive data securely for as long as you're legally or regulatorily required to. But once that retention period is over, you must securely destroy it.
And by securely, you mean in a way that it's forensically unrecoverable.
Absolutely, because data that you keep longer than you need to is just a liability waiting to happen. It expands your attack surface and increases your risk. If the data doesn't exist, it can't be stolen. It's the ultimate risk mitigation.
Let's talk about some of the specific technologies that help manage this life cycle. What's the role of DLP?
So data loss prevention is your workhorse for preventing data leakage. It uses those classification labels to identify sensitive data and then applies policies to stop it from being emailed, copied to a USB drive, or uploaded to an unauthorized cloud service.
And for the cloud specifically, you have CASBs or cloud access security brokers.
Right. A CASB sits between your users and your cloud services, like Office 365 or Salesforce. It gives you visibility into what data is going into the cloud and lets you enforce your security policies there. It's your main defense against shadow IT, where employees use personal cloud accounts for company data.
We also have techniques for minimizing the data itself, like masking and tokenization.
Yes, these are huge for privacy and compliance. Data minimization is the core principle. Just don't collect data you don't absolutely need. Then you have data masking, which hides part of the data like showing only the last 4 digits of a credit card. Tokenization goes a step further and replaces the sensitive data entirely with a random, meaningless token.
Which is huge for reducing the scope of things like PCI compliance.
Massively. And then there's anonymization, where you strip out all the personally identifiable information so the data can't be traced back to an individual.
Now, all of this work identification, valuation, classification, it has to feed into a formal risk management process. And that process is the business impact analysis, or BIA.
The BIA is the key deliverable. It's the formal process where you sit down with the business owners and you quantify the potential impacts of a disruption to their critical processes.
So you're asking questions like, if this system goes down, how much money do we lose per hour? What are the regulatory fines? What's the damage to our reputation?
Exactly those questions. And the output of the BIA is your justification. It's the hard data you use to prove to management why you need to spend X amount of money on security controls for a particular system. Without a BIA, you're just guessing at priorities.
And this isn't a one-time thing, is it?
Absolutely not. It has to be reviewed periodically. Businesses change, new products are launched, threats evolve. An outdated BIA is almost as dangerous as not having one at all because you end up protecting the wrong things.
Okay, that gives us the foundation. Now we need the structure to build on top of it. That means standards, frameworks, and documentation.
Right. And the key here is not to memorize every control and every framework, but to understand their purpose. Frameworks are there to keep you from having to reinvent the wheel. They're accelerators.
The source material puts them into three main buckets. The first is control frameworks.
These are the prescriptive ones. They tell you what specific controls to implement. Think of things like ISO 27002, NIST 853, or for a very specific industry, PCI DSS for credit cards. They're the checklists.
Then you have risk management frameworks.
These are more about the process. They tell you how to identify, assess, and manage risk. The big one here is the NIST Cybersecurity Framework, or CSF. It gives you that identify, protect, detect, respond, recover structure.
And the third type is security program management frameworks.
These are the highest level. They tell you how to govern and manage the entire program to make sure it's aligned with the business.
ISO 27001, which defines an Information Security Management System, or ISMS, is the global standard here. COBIT is another big one that focuses on governance.
So with all those options, how does a CISM choose which one to use?
You base it on your industry, your geography, and your maturity. If you're a U.S. federal contractor, you have to use NIST 853. If you're a global company that needs a certification to show customers, you'll probably go with ISO 27001. If you're a startup just trying to get the basics right, the NIST CSF is a great flexible place to start.
And all of this informs the Enterprise Information Security Architecture, or ISA. This is the security blueprint for the whole company. It's so critical. The ISA ensures that you're building security in a consistent, integrated way across the entire organization. Without that blueprint, you just end up with a bunch of siloed, incompatible security tools that don't talk to each other. It's a recipe for complexity and wasted money.
Let's pivot from the high-level frameworks to the nitty-gritty of documentation. We have this hierarchy: policies, standards, procedures, and guidelines.
Getting this hierarchy right is crucial. It's how you translate that high-level strategy into something an employee can actually follow day to day.
At the very top, you have the policy. This is the WHY.
Right. A policy is a high-level statement from management about intent. It's broad. It might say something like, the organization is committed to protecting the confidentiality, integrity, and availability of all information assets. It sets the tone from the top. It's mandatory.
Then, one level down, you have the standard. This is the what.
A standard makes the policy specific and measurable. If the policy says, we must encrypt sensitive data, the standard says all sensitive data at rest must be encrypted with AES 256. It's also mandatory. It defines the minimum acceptable bar.
Next is the procedure, the OUT-OW.
This is the step-by-step instruction manual. A procedure tells an employee exactly how to perform a specific task. Here are the 15 steps to follow when onboarding a new employee. It's a detailed checklist, mandatory.
And finally, at the bottom, the guideline, the COULD.
A guideline is a recommendation or a best practice. It is explicitly not mandatory. For example, we recommend you use a passphrase of at least 20 characters for your password. It's good advice, but you won't get in trouble for not following it.
The analogy of building a house works so well here. The policy is the blueprint, the standard is the mandatory building code, the procedure is the instruction manual for the plumber.
And the guideline is the interior design magazine suggesting a nice color for the walls. The failure happens when a manager tries to enforce an interior design tip and wastes energy on things that aren't mandatory requirements.
Which brings us full circle to our final topic, measuring success. All this work is great, but how do you prove to the business that it's actually working?
With metrics. This is how you demonstrate value, how you justify your budget, and how you make intelligent decisions about where to invest next.
But not all metrics are created equal. We've all seen dashboards full of useless numbers. What makes a metric effective?
It has to be smart, of course, specific, measurable, achievable, relevant, and time-bound. But the most important part, the real differentiator, is that it must be actionable.
What do you mean by that?
An actionable metric is one that drives a decision. If you look at the number and it doesn't cause you to change something, to reallocate resources, to update a policy, to start a new project, then collecting that metric was a waste of time.
So it's not just a vanity metric, like we blocked 1 million attacks.
Exactly. Who cares? A better actionable metric would be, Our mean time to patch critical vulnerabilities has decreased from 30 days to 7 days, reducing our window of exposure by 75%. That's an outcome. That's a result.
And you have to tailor these metrics for different audiences, right?
Yeah.
The board doesn't want the same report as the security operations team.
Not at all. At the strategic level, for the board, you report on big picture things. Overall risk posture, return on security investment, compliance with major regulations, high level tied to money.
Then at the management level, for someone like you, the CSMM.
There, I care about process efficiency. How are we doing on our audit findings? What's our policy compliance rate? How quickly are we provisioning access for new employees? I need metrics to help me manage the program itself.
And finally, down at the operational or technical level.
That's the real-time, day-to-day data. Patching timeliness, the number of open high-risk vulnerabilities from our last scan, incident response times. These are the metrics that drive the daily work of the technical teams.
There's also this important distinction between leading and lagging indicators.
Yes, and this is a sign of a really mature program. A lagging indicator tells you what already happened. For example, we had 10 security incidents last quarter. It's useful for historical analysis, but it's looking in the rearview mirror.
But what you really want are leading indicators.
You really do. A leading indicator is predictive. It suggests a future outcome. For example, an increase in the percentage of employees who report phishing emails is a great leading indicator. It suggests that your training is working and that you are less likely to suffer a major breach from a phishing attack in the future.
But metrics aren't the whole story, are they?
They're not. They're a critical piece of the puzzle, but they can't answer the ultimate question: how secure are we really? For that, you need the broader context you get from comprehensive risk assessments and independent audits. Metrics tell you if the individual parts are working. Audits tell you if the whole system is effective.
So, to wrap all of this up for you, the learner.
We've covered the entire development phase of a security program. We've established that the program is the engine, and it needs a formal charter to give it authority. It has to be built with security shifted left into the SDLC. And the whole thing is justified by knowing the value of your assets, classifying them properly, and then proving your success with actionable metrics that speak the language of the business.
Which sets us up perfectly for our next deep dive, Part B, where we'll move from the strategic development phase into the day-to-day of program management, designing, selecting, and implementing the actual controls.
But before we go, I want to leave you with a final thought to chew on, a real-world strategic problem.
Okay, lay it on us, the ultimate challenge.
We've established over and over that security has to be built in early shift left because it's cheaper and more effective. But what do you do when the business is moving faster than security can keep up? Imagine your company's leaders see a massive competitive advantage in a brand new emerging technology. Maybe it's advanced AI for logistics. Maybe it's quantum computing. The security requirements for this tech are completely undefined. The controls don't even exist yet. How do you, as the information security manager, justify a large immediate budget to start building a security architecture for that technology now, long before the cost of trying to retrofit it later becomes impossibly high?
Wow. So you're asking for money to solve a problem that doesn't technically exist yet, to prevent a future cost that is huge but completely theoretical today.
You are. You have to translate that deep uncertainty into a concrete financial risk that the board can understand and act on today.
That's a true strategic challenge. A great thought to take away. Thank you for diving deep with us into the foundation of security program development. We'll see you next time when we get into managing it all.
Stay informed and stay secure. Welcome back to the deep dive. If you've been following along, you'll know we've spent a lot of time in the strategic blueprints, the whole world of information security program development.
Right, the foundational documents, the risk strategies, all that planning.
Exactly. And today we are making a crucial pivot. We are leaving that planning room and, entering the ongoing operational reality of program management.
And that is a whole different ballgame. This is where your strategy actually meets execution. It's where all those beautifully written policies encounter real human behavior.
And where you, as the security leader, have to shift from being, say, an architect to being a vigilant operations manager day in and day out.
That shift is everything. It's about sustaining the program.
It is. Our deep dive today is, well, it's essentially the playbook for that. We're taking the theoretical framework we built and applying it to the real world. We're going to focus on 6 core pillars.
The whole life cycle of security controls.
Right. From selection through implementation, how you integrate them into IT, managing the human side of things.
Yeah. and then extending that out to your vendors, and finally proving it all works.
Testing and communicating success back to the business.
The mission for you, the listener, is really to get a shortcut to understanding that balance. It's always a balance between people, process, and technology. The CISM framework sees this as 5 critical, ongoing tasks.
So not just one-and-done projects.
No, never. It's about building a security-aware culture, integrating security into every process, not just IT, managing vendors through contracts, and then actually monitoring them. And of course, using metrics to prove you're effective.
So we're moving from those big upfront decisions to the daily, persistent vigilance required to keep the organization safe. It's the execution phase.
It's making sure all that foundational work we talked about last time actually survives contact with the real world, which, as we know, is chaotic.
Let's dive in.
Let's start with control design and selection. I mean, this is the absolute bedrock of any defense. A successful security program is never, ever defined by just one piece of technology.
It's that classic security triangle, right? Let's really flesh that out in a management context.
Absolutely. So first, you have people. And when we talk about people, it's not just hiring. It's about ensuring every single person understands risk management as it applies to their specific role.
So from the CEO all the way down.
All the way down. And that's guided by constant awareness, tailored training, and really, really clear roles and responsibilities.
Okay, and the second leg of the stool is process. That's where the administrative power really lies.
Process is the documented mechanism for enforcement. These are your policies, your standards, your guidelines, your hardening checklists. It's the how. It dictates how the organization behaves securely.
And finally, technology.
That's the easy part, in a way. Those are the tools, the firewalls, the MFA tokens, the encryption that you use to enforce the rules established by the process to protect the assets that are handled by the people.
And the most critical insight here, the thing we have to keep coming back to, is that security measures only exist to support business goals.
Say it again. It's so important.
We are not implementing a new firewall because it has cool new features. We're doing it to protect the financial app that generates 70% of the company's revenue.
Exactly. The control is the practical implementation of your policy.
Yeah.
But the guidance, the why, comes from the control objective. That's the clear statement of the desired result. For example, a high-level objective might be ensure the confidentiality of all customer financial data.
Okay, so that's the why.
Yeah.
The design steps then move us into the how, and it's all about risk management.
It's a 3-step cycle, and it never, ever ends. Step 1, identify your risks. What threats and vulnerabilities impact that customer data?
Step 2.
Define the acceptable risk level. Sometimes it's called tolerance. Basically, how much risk is the business willing to live with after the control is in place?
And then step 3 is actually designing the control to get the risk down to that level.
Precisely. To reduce the identified risk down to, or hopefully below, that acceptable residual level. The control objective then becomes your key metric for success. Did we achieve the result we wanted?
You mentioned that a single control objective almost never relies on just one control. It takes multiple types working together. How do we make sure that layered defense is actually effective?
Let's take an objective like logical access to our critical server farm is secure. That one objective needs controls from every single part of that triangle.
Give me an example.
Okay. The server's operating system permissions, the multi-factor authentication requirements, those are your technical controls.
Right.
The policy that requires a quarterly access review for all admins or annual background checks, that's an administrative control. It's paperwork, but it's powerful.
And then the physical side.
And the swipe card to get into the data center, the locked server rack, the surveillance cameras, those are all physical controls. If any one of those 3 categories is weak, the entire objective fails. It doesn't matter how strong the other 2 are.
And that really highlights the constant trade-off we face, doesn't it? Effectiveness versus usability.
Oh, absolutely.
If a control is technically perfect but so complicated that it grinds work to a halt, people are just going to find a way around it.
They will. And that brings us to the criteria for selecting controls. Yes, cost effectiveness is always the bottom line, but there are non-financial things that really matter to a security manager.
Like productivity impact.
Exactly. And user acceptance. A control should be as transparent as possible. We love controls that users don't even notice are there. Because if it significantly slows down legitimate work, you create instant resistance.
And if they try to bypass it, writing their complex password on a sticky note, the control is useless in practice.
It's worse than useless. It gives you a false sense of security. Its practical strength is 0, regardless of its inherent on-paper strength.
We also have to be looking forward. A control is a long-term investment, not a short-term fix.
Precisely. We need adaptability and scalability. Adaptability means the control can evolve with new threats. Can your IDS update its rules easily? Scalability means it can handle growth. What happens when you double your user base? Will the control fall over?
And what about its robustness? How well does it hold up to an actual attack?
That leads right into those fundamental policy questions about control failure. The classic one is fail-safe versus fail-open.
Right. How should a system react when it hits an error it doesn't understand?
As security people, our gut reaction is always fail-secure. Default to closed, default to restrictive. But a good manager has to understand the business and safety context.
You have to distinguish between what's safety critical and what's security critical.
Yes, a safety-critical system, like a fire door or hospital life support, absolutely must fail open. You want that door to unlock when the power goes out to save human lives.
But a security critical system is the opposite.
Completely. A banking application, a database vault, they must fail closed. If the firewall fails, it should block all traffic. Even if it interrupts the business, protecting the data is the paramount goal in that specific context. It's a foundational policy decision.
And that restrictive philosophy carries over. We almost always want restrictive versus permissive policies.
Always. Deny by default. Principle of least privilege. You only grant the absolute minimum access needed to do a job. Nothing more.
We also categorize controls by who manages them. You've got native, supplemental, and management support controls.
Right. Native controls are things built into the OS, like file permissions. They're usually managed by IT operations, which is why segregation of duties is so critical there.
And supplemental control.
Those are your add-ons, the firewalls, the MFA solutions. They're often managed by a specialized security team, but usually in collaboration with IT.
And then the management support controls.
Those are our tools, the CISM, the SOAR platform. They're the tools the security team uses to watch over everything else and see if the other controls are actually working. The ISM's job is to weave this all together into a defense-in-depth structure.
The focus isn't on a single product then.
Not at all. It's on the whole defensive structure. You look at the entire data path from the user all the way to the database, and you ensure that the combination of all these controls reduces the risk to an acceptable level.
Okay, let's zoom in on some of the enabling technology here, starting with PKI and cryptography, public key infrastructure. It's the core service for digital certificates.
And its resilience is a major managerial concern. If your PKI fails, authentication across the entire company could fail with it. The standard, most resilient setup is a 3-tier hierarchy.
The root CA, the subordinate, and the issuing CA.
Correct.
So why is the root CA always kept offline? And what's the actual point of that middle layer, the subordinate CA?
Okay, the root CA is your ultimate source of trust. It's kept offline in a vault because if it's ever compromised, your entire chain of trust is broken. You'd have to reissue every single certificate in the enterprise. It would be a catastrophe.
And the subordinate CA?
The subordinate or intermediate CA acts as a policy buffer. It's a managerial control. It gets its certificate from the offline root, and then it, in turn, issues certificates to the issuing CA.
And the issuing CA is the workhorse. It's online, handing out certificates to clients and servers every day.
Exactly, which also makes it the most likely to be attacked. The beauty of the 3-tier system is business continuity. If your online issuing CA gets compromised, it's not a disaster. You just revoke its certificate, take it offline, and spin up a new issuing CA from your still secure subordinate CA.
So you maintain operations without ever touching that precious root of trust.
That's the whole point. It's layered defense, but applied administratively.
Okay, so once these certificates are out there, we need to constantly check if they're still valid. We have two methods, CRL and OCSB.
The old way is the Certificate Revocation List, or CRL. The client has to download this potentially massive file of every single revoked certificate. In a big company, that file gets huge, fast. It eats bandwidth that slows down transactions. It's an operational headache.
And OCSP is the modern solution to that headache.
It is. The Online Certificate Status Protocol. Instead of downloading the whole list, the client just pings the CA and asks, hey, is this one specific certificate still good? The response is tiny and fast. From a management perspective focused on speed and user experience, OCSP is a no-brainer.
Let's quickly hit the goals of cryptography. We have the classic CIA triad confidentiality, integrity, authentication, but we add a fourth, non-repudiation.
Non-repudiation is so critical, especially in finance or legal. It provides absolute, irrefutable proof that someone was involved in a transaction. It prevents them from denying it later.
And this capability is really what dictates our choice between symmetric and asymmetric systems.
Absolutely. Symmetric crypto, like AES, uses one shared secret key. It's incredibly fast, which makes it perfect for encrypting huge amounts of data. But the management is a nightmare.
How do you get that one secret key out to thousands of people securely?
You can't, really.
Yeah.
Not at scale. And because everyone has the same key, you can't get non-repudiation.
Which is why the slower but more scalable asymmetric crypto with its public and private key pairs is so vital for management.
It is. It's slower for bulk encryption, but it completely solves that pre-distribution nightmare. You just publish your public key for everyone to use. And because only you have the private key, it's the only way to do digital signatures and get true non-repudiation.
So the elegant solution is to use both.
The elegant solution is to use the slow, scalable asymmetric crypto only to securely exchange the fast, efficient symmetric key. Then you use that symmetric key for the actual data transfer. Best of both worlds.
Perfect. Lastly, hashing. A one-way function used for integrity. What's the one non-negotiable requirement for a good hashing algorithm?
It has to be collision-free. Every unique input has to generate a unique output. If two different files can produce the same hash that's a collision, then the integrity check is worthless. That's why we don't use old algorithms like MD5 anymore.
Okay, so that's design. Let's move into the messy reality of implementation and integration. We're shifting from designing the perfect policy to actually making it stick.
Right, we already talked about the three categories: technical, administrative, physical. But the real insight for a manager comes from classifying them by their function. The 6 types give you the vocabulary you need to build a truly layered defense.
Okay, let's make this memorable. Give me a specific example for each of the 6.
All right, number 1, deterrent. This just discourages a violation. A great example is a policy that says all network traffic is monitored, displayed right on the login screen. It makes people think twice.
Number 2, preventative.
This stops bad things from happening. A firewall blocking a port, strong 2-factor authentication. That's preventative.
Okay. Detective?
This discovers things after they've happened or while they're happening. A SIM alert for 10 failed logins from one IP address. Or just simple audit trails that log what an admin does.
What about compensating?
This is a backup control. It's what you do when the main control isn't possible.
Yes.
So if a small team can't do proper segregation of duties, they compensate with increased monitoring and mandatory peer reviews of all changes.
Makes sense. Then corrective.
This fixes things and gets you back to normal. An automated patch that fixes a vulnerability. Restoring from a backup after a ransomware attack. That's corrective action.
And finally, directive.
This directs people to do the right thing. Your acceptable use policy that says you must use the corporate VPN for remote access. It's a direct order, essentially.
That brings up a great point. Control overlap. A single control can serve multiple functions. How do we use that idea strategically?
You use it to justify your investments. A security camera is the perfect example. It's a deterrent, it discourages theft, but it's also a crucial detective control. It gives you the video evidence you need later. When you classify controls, the context of your own defense structure is what matters.
Let's talk about control baselines. This is a key administrative tool for standardizing security. Why is having a documented baseline so important for a manager?
It removes ambiguity. It standardizes security across your entire fleet. A control baseline is a predefined minimum set of controls like required authentication strength, default logging settings. That has to be applied to all systems of a certain data classification.
So if a new server holds top secret data, it automatically gets the top secret baseline of controls.
Exactly. No debate, no discussion. It's the documented standard.
So as the information security manager, what's my role when a new system is being developed and these baselines are being applied?
Your due diligence is everything. You evaluate the proposed system against that baseline. That's your gap analysis. You coordinate the testing. And this is critical. If you find a gap that can't be fixed, you must ensure senior management formally reviews and documents their acceptance of that residual risk before it goes live. You are the gatekeeper.
And this is the operational reality of that shift left idea we hear so much about.
It is. If you try to bolt security on at the end of a project, it's a disaster. It's expensive, it causes delays, and it's never as effective. Integration means security has to be in the conversation from the very first design meeting. Security has to be seen as an enabler, not a roadblock.
Let's talk about integrating security into those core IT processes, starting with the crazy fast world of DevOps and DevSecOps.
The business today wants multiple software releases per day. You can't have a human manually reviewing every line of code. DevSecOps is about embedding automated security testing right into the CI/CD pipeline.
So it happens automatically.
It has to. It forces security validation to keep pace with development. You find the vulnerability in the developer's desktop, not after it's been deployed to thousands of customers.
Then you have change management. The Change Approval Board, or CAB, has to have a security person at the table.
It is non-negotiable. Security must have a voice and a vote at the CAB. Any change, a router config, a new app, a firewall rule, has to go through a risk analysis to see how it impacts the overall security posture.
And we know that misconfigurations are still a leading cause of breaches. How does configuration management help with that?
Configuration management systems enforce your standards. They automate the deployment of your security baselines and hardening guides. The managerial benefit here is enormous. Automation dramatically reduces the risk of human error or, an overworked admin taking an insecure shortcut.
And finally, release management.
The last checkpoint. All security testing, pen testing, code review, whatever is required, must be demonstrably complete before anything goes live. It's about minimizing the risk of a rushed, insecure launch.
Let's shift to our second tech deep dive. Cloud and network virtualization. These are everywhere now. Let's start with the cloud deployment models.
From a management view, the deployment model defines your budget and your responsibility. Private cloud is your on-prem data center. You have total control, but also total cost and responsibility. Public cloud, you're using a CSP's hardware, paying as you go.
And the most common one for big companies is hybrid cloud.
Right, and hybrid is complex because you're sharing responsibility, you're connecting your on-prem world to the public cloud, and you have to make sure your security policies are consistent across both environments.
Which brings us to the shared responsibility model. This is something every security manager has to know cold.
You have to. In IaaS, infrastructure as a service, the cloud provider handles the physical security of the cloud. But you, the customer, are responsible for patching the OS, configuring the network, securing the app, and the data security in the cloud.
And in PATS, platform as a service, the provider takes on even more.
They do. They manage the OS and the middleware. You just focus on your application code and your data.
And then with SaaS, software as a service, like your email provider, the CSP manages almost everything.
Almost. But you never get off the hook completely. You are always responsible for access management, for configuration, and critically, for having a backup plan for your data, even if they say they handle it. You can't just assume.
Let's talk virtualization risks. VM escape and VM sprawl are huge managerial headaches.
VM escape is the nightmare scenario. An attacker breaks out of their virtual machine and attacks the underlying host, potentially getting access to every other VM on that box. Mitigation is all about management. Rigorous patching of the hypervisor, keeping guest privileges low, and using host-based intrusion detection.
And VM sprawl?
The operational management nightmare. This is just the uncontrolled creation of virtual machines that are unpatched, forgotten, and vulnerable. And in the public cloud, they're also a huge hidden cost. You need strict administrative controls to manage their lifecycle.
Shifting to network segmentation, this is all about limiting an attacker's lateral movement.
Right. We use VLANs to logically divide a network. But the classic architecture that dictates policy is the three-interface firewall design.
How does that design enforce policy?
It creates three distinct zones. The external interface faces the internet, deny everything. The internal interface connects to your trusted employee network, highly protected. And the crucial middle ground is the DMZ, the demilitarized zone.
That's where you put your public-facing web server.
Exactly. They have to talk to the outside world. This design ensures that if a server in the DMZ gets compromised, the attacker is still stuck. They haven't reached your internal network yet.
For connectivity, we use VPNs. And the difference between transport mode and tunnel mode is a key decision.
It is. Transport mode just encrypts the data itself, leaving the headers alone. It's often used for client-to-site VPNs. Tunnel mode is a full package. It takes the entire original packet, encrypts it, and wraps it in a new one. It's the standard for secure site-to-site connections.
And finally, the philosophy that's turned everything on its head, zero trust architecture.
Zero trust kills the old idea that inside is safe. It dictates that no entity is trusted by default, no matter where it is. It's a massive shift based on three pillars. Assume breach, verify explicitly for every single access attempt, and enforce least privilege access at all times.
We've built the tech and the process. Now we have to deal with the biggest variable of all, the people. The goal is creating a true security-aware culture.
This is a pure management challenge. Human error and social engineering are still the #1 way attackers get in. So we have to embed security thinking into everyone's daily tasks, and that requires a robust, ongoing, specific training program.
What are the principles of training that's actually effective, not just a check-the-box exercise?
3 things: relevance, consistency, and reach. Relevance means connecting the training to the person's actual job. An HR manager needs different training than a developer.
Consistent.
It has to be continuous, not just once a year. And reach means everyone with access gets trained, including your contractors and temporary staff.
So what are we training them on, beyond the basics?
High-impact stuff. How to spot phishing and sophisticated social engineering, password best practices. But the most important outcome is fostering an open culture.
Explain that. Why is a culture of fear the enemy of good security?
Because if your employees are afraid of being punished for making a mistake, like clicking a bad link, they will hide it. And a hidden mistake festers and becomes a massive breach. We have to create a culture where the mantra is, if you see something, say something, and if you think you clicked something, tell us immediately. We're here to help, not to punish.
So security has to be a support function, not just the police.
Absolutely.
Yeah.
And that means the training has to be tailored. One size fits all is just a compliance formality.
So executives get different training.
They have to. Executives need training on risk appetite, on their fiduciary duties, on ethical leadership. They set the tone. People with elevated privileges need constant training on their heightened responsibilities. Even physical security guards need specific training on things that maintain CIA, like power stability and fire suppression.
Beyond just computer-based training, what are some effective ways to reinforce this?
A mix is key: email reminders, posters, login banners. But the single most powerful tool for a manager is the visible enforcement of the rules. When people see that policies are taken seriously, with tiered reprimands for repeat violations, they understand it's not optional.
Let's move to accountability. This gets messy. We have to clearly define role versus responsibility.
A role is who does something, the database administrator. The responsibility is what they must do. Apply patches within 48 hours. We use tools like RACI charts to make this crystal clear. Who is responsible, accountable, consulted, and informed?
And to prevent conflicts of interest, we have segregation of duties, SOD.
A classic control. It prevents one person from having end-to-end control over a sensitive process. A developer should not be able to deploy their own code to production without an independent review.
But what if you're a small company or just a small team? You might not have enough people for a robust SOD.
A very common problem, and that's where you need compensating controls. There are 2 big ones. First, increased monitoring and alerting. If one person has the keys to the kingdom, you turn up the logging and auditing on that account way up.
Okay. And the second one is often a tough sell, mandatory vacations.
It is, but it's one of the most effective non-technical controls ever invented. It forces someone else to do that person's job. This uncovers 2 things: fraud that can only be hidden with constant control, and it prevents those dangerous knowledge silos where only one person knows how a critical system works.
And making sure all this governance happens at a high level is the job of the Information Security Steering Committee, ISSC.
Right. The ISSC is your formal governing body. It's made up of senior leaders from across the business: IT, legal, HR, finance. Their job isn't to configure firewalls. Their job is to approve major policy changes, own the security strategy, and make sure it stays aligned with the business's risk appetite.
So today's world means we are relying more and more on external services cloud providers, MSSPs. This creates a huge supply chain risk. What's the core principle here?
The golden rule. You can outsource the task, but you can never, ever outsource the accountability. The ultimate responsibility for your data stays with you no matter whose server it's on.
What are the biggest challenges a manager faces with vendors?
Oh, there are many. Misaligned security processes, tech incompatibilities, and a big one is weakness in their capabilities, like their disaster recovery or incident response plans.
So the mandate for the security manager is to get involved before the contract is signed.
You have to. That's the first phase of managing third parties. Before the contract, you do your due diligence, you send questionnaires, you demand to see their policies, you include legally enforceable risk clauses in the contract.
And what about during the relationship?
That's the day-to-day management. You're doing continuous monitoring, having status meetings, and you have to trigger a formal reassessment if anything significant changes, like if they get acquired or ask for more access to your systems.
And the final phase, conclusion or offboarding, is often overlooked.
It is, and it's so dangerous. You have to plan your exit strategy from day 1 to avoid vendor lock-in. When the contract ends, You need formal, auditable processes to make sure all your data is returned or destroyed and all other access is immediately cut off.
Let's get specific on those contract clauses. This is where you enforce accountability legally.
Okay, number 1, security controls. The contract must define the mandatory controls they have to implement, often referencing a standard like ISO 27001.
2, right to audit.
Non-negotiable for high-risk vendors. You define the scope, the frequency, maybe even the right to do unannounced audits.
But you can't just tell Amazon you're sending your audit team over on Tuesday. How do you handle that with the big cloud providers?
You can't. So you accept assurance documentation as a substitute. For a major CSP, you require something like a SOC2 Type 2 report. That's an independent auditor's report saying their controls have been working effectively over a period of time. It's your managerial due diligence.
Next clause, incident response.
Crucial for regulatory compliance. You must have clearly defined roles and, most importantly, notification timelines. A delay here could cost you millions in fines under GDPR or IPA.
And liability, this is where the lawyers really earn their money.
Right, indemnity and liability caps. You have to make sure the contract provides compensation if they fail. And you have to scrutinize their liability caps. If a vendor is handling data that could cost you $100 million in fines and their liability is capped at $5 million, that is a massive residual risk that senior management needs to formally accept.
And finally, data protection.
This clause specifies exactly where your data is stored. Is it required to stay onshore? And who is allowed to access it? This is all about meeting data residency and sovereignty rules.
So once all these controls and contracts are in place, the management function shifts to evaluation. What's the whole point of constantly testing and evaluating?
The purpose is to make sure the controls are still effective in the real world, keeping your residual risk at an acceptable level. Controls aren't static. Threats evolve, businesses change. If you don't check them, they become useless.
So what are the common methods we use to check them?
There are a few. Periodic internal and external assessments, internal audits to check against policy, and continuous monitoring tools. And of course, the big one is penetration testing, simulating a real-world attack to find weaknesses you'd otherwise miss.
Let's revisit that distinction between inherent strength and practical strength. This is so important for a manager.
It is. Inherent strength is the on-paper, theoretical robustness of a control, the quality of the encryption algorithm. Practical strength is how effective it is in the real world. If a theoretically great control is so complex that users find ways around it, its practical strength is zero.
The lesson is that complexity is often the enemy of practical strength.
It is. Which is why we emphasize layered defense. If one complex layer fails, a simpler, more robust one is there to back it up.
And we have to get past the automation myth.
Oh, absolutely.
Yeah.
Just because a control is automated doesn't mean it's effective. An effective manual control, like a guard doing unpredictable rounds, is far better than an ineffective automated one, like forcing 30-day password changes that just lead to people writing them down. Real-world performance is all that matters.
To make sure this evaluation is continuous, we align it with the Plan-Do-Check Act, PDCA cycle.
It's the cycle of constant improvement. 1. Plan. Design your strategy and policies. 2. Do. Implement your controls and integrate them. 3. Check. Monitor, audit, and review their effectiveness using clear metrics.
And those metrics have to be relevant, measurable, and actionable.
They have to be. And 4. Act. Based on what you find, you implement corrective actions, and you escalate recommendations and resource requests back up to management.
A critical task for any security manager is the program evaluation. It's the health check. What are the key areas you have to look at?
3 main areas. First, compliance. Are we meeting all our legal and regulatory requirements? Are we tracking and fixing audit findings? Second, accountability and oversight. Are the roles clear? Is the steering committee actually meeting and providing guidance? Remember, if accountability is unclear, no one is accountable.
And third, resources.
Right. Do we have enough money, enough skilled people, and enough technology to do the job?
And if you find a shortfall, let's say your security team is critically understaffed, what is your immediate duty as a manager?
Formal escalation. You have to document the shortfall, link it directly to a tangible, increased business risk like we can't patch critical vulnerabilities fast enough, and present that justification for more resources immediately to senior management. Your job is to inform them of the risk. Their job is to decide what to do about it.
Finally, communication and reporting. The task here is translating technical risk into business impact.
Exactly. Your reports have to fulfill the promises you made in your original business case. They need to be tailored to the audience. Senior leaders don't care about firewall rule counts. They care about risk reduction, compliance, and cost effectiveness. You report on metrics like annualized loss expectancy, incident trends, and the total cost of ownership of the security program.
And let's bring back that crucial, counterintuitive metric for measuring the effectiveness of awareness training.
Right. Most people think success is when the number of security incidents goes down. That is often a fallacy. The single best indicator that your awareness training is working is when you see more reported incidents.
Explain that distinction. It's so profound.
If your employees feel safe to report, and they've been trained on what to look for, they will report everything suspicious. Every weird email, every strange phone call. This gives your security team invaluable early warning data. If you have 0 reported incidents, it doesn't mean you're perfectly secure. It probably means your culture is closed and your users are hiding mistakes or just don't know what to look for.
So effective training creates vigilance, and vigilance shows up as more reports.
That's it. We've seen that the jump from program development to management is all about constant operational maintenance, strategic resource fights, and just a deep understanding of how tech, process, and people all interact. It's a perpetual balancing act.
Absolutely. We've gone from control selection to shifting left into DevSecOps, formalizing accountability, extending that vigilance out to our vendors with tough contracts, and finally, measuring success in ways that actually matter.
It all boils down to measurable, sustainable execution. You have to constantly check your work and be ready to adapt.
So, here's a provocative thought for you, the listener, to explore further. We discussed how complexity can destroy a control's practical strength, leading people to work around it. Considering how critical accountability and compliance are, what specific non-technical control beyond awareness training do you believe is the single most bypassed administrative control in large organizations today? And what specific business metric would you use to prove its failure to senior management? Think hard about documentation and adherence, and join us next time for our next deep dive.